Hello, everyone. Welcome to today's episode. And in this episode, we'll be looking at how to find the midpoint or the median, and also working with percentiles for a multi-dimensional data set. Now, we want to conserve all the properties of the net CDF data set, even though we are using the Xarray. And so we wouldn't want to just use NP median or NP percentile, so that the coordinates and then the dimensions are lost, right? And so let's start off by running this, which is making use of the crude data set, and then making use of Xarray to open the data set, and then we select the TMP variable, and we make a selection for a particular region, now in this case being West Africa. Okay. So I didn't need to group by time the year. In this case, this would give us the annual information. All right, so and with this done now, you can see what the data contains, and the dimensions of the data. So we type in data, we see it contains the longitude, the latitude, and then the year. Now this time the time has been changed to year because we did a group by and then found the average over the time to change this into yearly averages. All right, so now let's say we want to find the median or the midpoint. So let's call this mid. Now what we will do is, if I just use NP from the NumPy, and then I just find NP dot median of data, that would work. But then the properties we are seeing here, like the coordinates and the rest, would all be lost. So what we can do is now to call the data itself, and then we add a reduce function, which is something that Xarray understands. So we added reduce function, and within the reduce function, we pass in the actual function we want to make use of, which is in this case the np.median. Right, and if you if you don't want to include the nonce, that's the missing values, then you make it np.non-median, so that if there's any missing value, it's if there are nonce, they are taken out before the midpoint is identified. And then so we can also include the dimension we want to compute it over. I want this over the year dimension, so that in the end we have a two-dimensional. The longitude and the latitudes are preserved. So if we run this part, right, we have our mid. Now we can look at the shape of the mid, and that's two-dimensional, no longer three-dimensional. It means the year it's found the midpoint for each grade per their years. So now we can also again plot what we see, what we have in there, and that gives us a clear indication of what the midpoint is. So that's an easy way of finding the median. Now we can use the same approach for the percentile. So let me duplicate this and rename this the percentile. So what we are going to use in here as the function would be np.non-percentile, which is again to omit the nonce. And then percentiles also have quartiles, so we indicate the quartile. So Q equals to, so let's say 95, which is the 95th percentile, and then the dimension to compute over. All right, so if we rerun this, we have the 95th percentiles computed. So if we find the shape of the percentile, now there's also two-dimensional again, because we've decomposed the time component. So we can again plot this out to see what the percentile values are. And that's what we have for the percentiles. Once we have this, it's easy to find the difference between the percentiles and the midpoint and just plot them. So this is just to be clear that you are not getting the same values, right? Unless of course the midpoints are the 95th percentiles, which wouldn't be the case. All right, so we run this and we see the differences. And that's an easy approach of, finding the median or certain percentiles of your data set. I believe you enjoyed this session. If you have any question, leave it in the comment box and the team would address it. Don't forget to keep learning and keep growing. And if you're new here, don't forget to subscribe. If to our returning subscribers, would say thanks a lot for sticking with us. And let's keep learning together and growing together. Have a wonderful time. Bye-bye.